Hi, everyone. Thank you for coming to Think Big Analytics webinar today. Today's topic is using big data to modernize, in which we will talk about one of Think Big's customers, Kantar Media Intelligence, which is a subsidiary of WPP, and the work that we did during one of our Jumpstart projects. Two people will be presenting today. We have Will Rompala, VP of Production Systems at Kantar Media, as well as one of our own, Joe Kelly, who's a data engineer here at Think Big Analytics. This webinar will be recorded, and you can find it on our website under our recorded webinars. And I will be addressing all questions at the end of the webinar. Please feel free to send any questions over using the control panel, and I will get to them by the end. Thanks a lot, and now I pass it off to Will.
Hello, good morning. Again, my name is Will Rompala, VP of Production Systems at Kantar Media. I'm going to be sharing today a little bit of actually the pretty exciting success we had in a big data project. Just want to give a little bit of background just so you knew who we are. Kantar Media, we're actually part of WPP, very large family of agencies and other technology and data companies. What do we do as KMI? We actually provide monitoring and data on advertising activities globally. So we these days, of course, these stats are out of date the moment you put them on a slide, but we do report on 96% of all the global ad activity that's going on out there. In the U.S., which is the area that my division, technology division, is responsible for, we monitor millions and millions of products, ad occurrences, and that sort of thing. So we're part of a larger family of a bunch of different parts of Kantar Media, but we focus on the advertising intelligence section. We actually have monitoring arms of our company that monitor everything from digital clickstream data to magazine data, movie trailers, political advertising, that sort of thing. But I want to talk a bit about what we ended up doing and how we are leveraging big data to try and to truly modernize or shift the ability of us to gain further insight into data that would have been completely unachievable based on the way we were collecting our data before, and how we were able to use a Jumpstart program to get us going and gain brand new data sets, and also and because of that, and then creating brand new insights. In this project, we had let me give you a little background as to what our existing operations would be. What we do is we collect advertising occurrence data. We're using primarily a spidering technology this is for online web advertising. We use a spidering technology where we go out and sample statistically significantly the advertising found on websites, whether they're display advertising or video advertising. That's one area. We cover 26 different media, but in this discussion, we're talking internet. Now, we've had success with that, and we were approached by a very large video portal to potentially, let's start talking about moving into more of a census level measurement, because they do extensive amounts of targeting, video targeting, and audience, and they wanted to make sure that their data was represented properly in our data reporting, because our customers use that data to make very strategic and very timely decisions as to where to place their advertising. So when we had this conversation, we realized that there were certain challenges around being able to measure them, because we could not sample that data. They were behind. They were certainly a walled garden. Their data was encrypted, and besides, we wanted to be able to get that census level data instead. So we certainly had some conversations around this, and the direct measurement was immediately put out there on the table as the approach we should take. However, direct measurement of a shall we say, one of the, not the largest uh, video advertising by volume online video networks, would it certainly has some challenges, not to least which is cost in just investment on trying to handle the transaction volume you're talking about. We're looking at 1,500 to 2,000 transactions per second. We needed to be able to handle scale, not just today, but of course peaks and future scale. We know we needed to have something that could turn around some sort of beacon reception, sub-second beacon reception, because obviously latency is a problem for everybody involved. We could not impact the customer experience, their customer experience, just because we're measuring. Not to mention we have bandwidth and depreciation and how do you scale, et cetera, et cetera. So really, what we were looking at is not only cost but also that speed. About latency, just a couple more seconds about it. This partner would be sending us United States traffic at first. At least our Rev 1 is US only, but there's no reason why we can't go further than that. Not to mention, when you're talking about beaconing, beacon transactions coming from a video experience, those beacons are being transmitted by the consumer's computer, not by the video producer or the publisher. So this means if we have a data center on the East Coast and we have customers on the West Coast, of course, whenever you add any sort of distance, you're adding some sort of network latency. So we wanted to make sure that whatever solution we came up with, we wanted to make sure that it would be able to scale, and if we were having issues about latency or distance, we would be able to solve that easily. Of course, the third barrier that we had to think about was training. Certainly, moving into this type of architecture, we know we didn't have a heck of a lot of ready, available knowledge right at our fingertips in-house. So we wanted to make sure that we had some sort of solution or help that would help us get through this. So when we looked through all of these things, and we looked at all the different vendors out there, we certainly it was clear, there was no doubt about it, that Amazon Web Services was our primary, or really the best vendor of choice out there to give us that kind of scalable, as well as affordable cloud storage and cloud and hosting environment that could scale with what we needed, but also gave us that international or national footprint. When I went and talked with AWS, they pointed me in the direction of ThinkBig, who could help us get jump started, which was wonderful. Actually, they helped us with strategy, the requirements vetting, actually the architecture implementation, and then the training, everything we needed. It really allowed us to get out of off the starting blocks with giving us that support to help us move forward. Now, as we're going to go into some of the system architecture slides, I should let me hand this one over, or we're having a poll first.
We will be having a poll. If you could just go to the next slide.
Okay, sure. Sorry, a little latency there.
Yeah, no worries. All right, so here's our first poll, everyone. So let's launch it here. How advanced is your organization in using big data? Just starting, considering use cases, completed several projects, or advanced? Give some people time to reply. All right, just to share you the results, the plurality of everyone on the line here are considering use cases. As you can see, a lot of people are in the earlier stages on this call, but it's also reassuring to see that some people are in the advanced stages and using big data. All right, so we'll now transition over to Joe Kelly.
Thanks, Matt. Thanks, Will. Again, my name is Joe Kelly. I'm an engineer with ThinkBig. To give you just a tiny bit more background about Think Big Analytics, in case you aren't familiar with us, we do provide professional services, or a range of services for big data, everything from planning and design to actual development and then training. And as I mentioned, I'm an engineer, so I'm primarily involved with the Kantar project. So just to start off with a little bit more background, I'd like to explain kind of the environment and the problem that we walked into with this project. So as Will explained, the video hosting network was going to add a tracking tool to their website that would send data directly to Kantar each time a user views an ad. This data comes from the embedded video players, and the system that we built had to receive all a daily report showing aggregates by event and by ad type. So when I say event, that could be a user starts watching an ad, finishes watching an ad, clicks on an ad, etc. To go into a little bit more detail about the requirements of the actual data, first of all, their data retention is expected to be 90 days of raw data stored. Each event sent to our system is relatively small, so only between 5 and 13 kilobytes per event, but this is still a very large video network, so there's going to be a maximum of 45 million calls per day with an expected peak rate of 1,200 per second sustained for 6 hours. So that gives you a little bit of an idea of the scale and the targets that we were trying to hit with our system. And also, as Will mentioned, latency was another concern, huge concern, something that we really wanted to keep in mind with our whole design and with our development of the system. So to dive in a little bit into the actual architecture that we came up with, first of all, we definitely agreed with going with AWS. Perfectly fits both the budget and business requirements for the project. Then as we started discussing the actual architecture that would be on AWS, we collaborated to select from a variety of different approaches, but each of those approaches had a common kind of high-level view. First of all, we would have one or more stateless web servers to receive these requests from the video player. And of course, those would be behind a load balancer so that it's just one URL from the external view. Each request needed to be immediately stored in a temporary warehouse with fast responses. Again, latency was the huge thing here. We didn't want to be hanging with these requests for any significant amount of time. The goal is to get it in the range of tens of milliseconds if possible. So we wanted to pick a type of storage that would allow us to write as quickly as possible, as low latency as possible. After that, the data would be periodically removed from that temporary storage and moved to S3 for semi-permanent storage. That's where the 90-day retention period comes into play. And then from there, using Amazon's Elastic MapReduce, we could generate reports over that storage daily. And then once those reports are generated, store it right back into that same long-term storage. All right, let me get to the right slide here. There we go. So Will talked about scaling a little bit. And I just wanted to point out that All right, I just wanted to show a little bit how that actually plays out on AWS. So the gray parts of the slide scale automatically in AWS, and there's not much manual intervention that needs to be taken. At worst, it's a matter of clicking a few buttons just to add a number of, add more nodes or more capacity, anything like that. At best, it happens automatically without any intervention. So the elastic load balancer in front, there's no intervention needed there. That has pretty much infinite capacity. The SQS, the simple queue service, again, pretty much infinite capacity. S3, same thing. Elastic MapReduce is just a matter of specifying how many compute nodes and of what size you need. Scaling in the non-AWS world, so for the web servers and for the workers that are pulling from the queue and then pushing out to S3, it's just a matter of adding more nodes. This step of the process is kind of trivially parallelizable, so it's extremely easy to add more nodes as more are needed. The key thing to note here from a business perspective is that horizontal scaling is happening on demand and not in advance. There's no need to spend months planning ahead of time or guessing at how much capacity you're going to need. You can actually just look at how much you have now and almost instantly scale to meet your current demand. So another great thing about the AWS platform is that EMR handles services like the name node and the job tracker automatically for you. This greatly simplifies the architecture from a support standpoint, but there's more to it. AWS implicitly separates the compute and the storage. So in an on-site environment, each of your cluster nodes act as both a data node and compute node. So this AWS separating the two creates a world where adding new data nodes is easy and scaling your data center is easy. But it's even deeper than that. A very common use case is the need to make data accessible to researchers, to development workers, to anybody who kind of needs ad hoc access to the data. However, you generally don't want that kind of stuff running on the actual production cluster. The ad hoc queries and the research queries can be slow. They can consume a lot of resources. And it's common to have queries be really complex. But with that complexity, one error can almost totally bring down a cluster. As an example, there was an instance where there was an error in a pig script, just a small little typo that caused a fork bomb, and a researcher brought down a production cluster. With an on-site solution, the solution to this is obviously to have many different clusters. We have a production cluster, a test cluster, a dev cluster, etc. But mirroring the data between those is difficult and expensive, and sampling sometimes is not good enough for the researchers. They really do want access to all of the data, the full data set. With AWS, handling all this is a snap. You can create separate compute clusters for research, for ad hoc queries, development, easily and safely. With ad hoc, you're ready to drive new insights and new products. So before I get into best practices, Matt is going to launch another poll.
Thank you, Joe. Here is our second poll here. Is there a business sponsor for your big data project? Wait for a couple more of you to vote. All right, so very large percentage, 80% voted for no, there is not a business sponsor for your big data project, which really alludes to the idea that a lot of this research and development type projects happen within IT itself. Okay, pass it back to you, Joe.
They just haven't seen the light yet, right?
Exactly.
Okay, so I'll walk through a little bit about best practices that ThinkBig likes to take when doing a jumpstart like this. The first stage is obviously planning. Our practice is to interview business and technology stakeholders to identify and define the best use case. Some of the factors that we take into account, first of all, the amount of data, the velocity of data, just pure numbers there. Next is the technical readiness. So what stage our client is at. Next is the skills gaps. So what kind of skills does our client have, and where are the gaps there, and how do we meet those gaps? And lastly, budget, of course. So that is typically what composes our first week. During the second week, we try to develop an initial proof of concept, basic functionality, end-to-end system. Once you have the basic functionality in place, then you can start to scale up a little bit, gradually work up towards the scaling that you need to meet your actual production requirements. Also at this stage, we deliver definition and design documents, so definition in terms of what we're actually doing, design, and how that's going to get done. After that, next week 3, we complete testing of the system. In the case of Kantar, we improve scaling, doing things like compression, making sure all of our latencies were where we wanted them, making sure the throughput was where we wanted it. And then lastly, final week was training. So this includes both training specific to the system that we've built and delivered, as well as more general training for AWS, for Hadoop, Hive, Pig, etc. So the sky's the limit on insights that may be driven in the future. There's no barrier to ad hoc research, what-if scenarios. I think that was one of the key wins that we really were able to deliver with this project. Ability to do all of these new kind of research ad hoc queries on the data in a safe platform that is not a barrier to innovation. That's the best benefit of all.
That's right, Joe. If I can hop in there, one quick second there. So really, what I guess the benefit of this platform when it ties into product. Let me throw a couple more seconds. I didn't mention some of what we were actually doing there. So what allowed us to do is to not throw any data away. Okay, so that was the biggest kick for us, because as you know, working on the project, there's data in there that we're not using currently. We're not extracting, we're not pulling it down, we're not doing any insights on it, because we don't know what we don't know in the future, right? So one of the biggest things that we enjoy in this is that since S3, it's unlimited. We don't have to worry about storage costs. I mean, I can tell you the storage cost that I'm paying right now is a rounding error compared to any other costs. I mean, so store all of your data. I'm throwing everything that I'm getting into S3. We're not even thinking about it. The other thing is that the reason I'm doing that is because I don't know where I'm going to be looking for in the future, and there may be some data in there that we're not going to want to have thrown away. Second, moving into this direct measurement census level data set, it allows us now to do the type of insights on our data we couldn't do today with using a statistically sample approach. Our current sampling approach allows us to figure out how many exposures there were and estimation. Obviously, with census, we get much higher quality data that allows us our products to be revolutionarily better. But on top of that, it also allows us to go for additional insights. We can now derive out of that data geo-targeted information. So, we could never think about wading through 45 million rows every single day over a campaign lifetime using traditional tools, but we can using this to say, let me see which one of these creatives were being exposed only in a certain geographic region, about a certain DMA. That type of capability that we're pushing into our products now was completely impossible, not able to be done at all under our older technology, but now using this the big data technology, using Hadoop to doing this kind of analysis to us, it allows us to completely revolutionize our product. Sorry, I just want to jump in and just add that little bit at the end there, Joe.
Oh, that's great. Thanks.
All right. Well, we have a couple.
Thank you for attending. I think we.
Yeah. Thanks,
Okay.
Joe. I think we do have a couple of questions here, but if you have any questions at all related to the content of this webinar or the project that Think Big was able to do with Will Rompala at Kantar Media Intelligence, please just use the questions area of the control panel and just send them over. So both for you, Joe, and Will, when selecting the specific AWS components for the architecture, why the selection of those particular items like S3 and EMR versus different technologies like EC2 or things like that?
Sure, I think I can handle this one if that's all right.
Mm-hmm.
So I guess I'll walk through each different component. First of all, SQS, the queue service, we chose as low latency initial data store. We had also considered using Amazon's DynamoDB.
I throw a whiteboard analysis up there for you.
Yeah, I think you can actually see Dynamo there at the top on the whiteboard.
Yeah, we did actually go through a number of these.
Yeah, anyway, we later decided that Dynamo was more complex than what we needed and would be higher cost than SQS. We only really needed a place to permanently store something, or I guess I should say not permanently, resiliently store something, and then later move it to S3. And the latency was really the key requirement, and SQS easily met that latency. We definitely see around 10 millisecond latency times with SQS. S3 is really just a great general purpose file storage system. Infinite scalability, infinite access, and it's pretty cheap. And EMR is really great for all sorts of different processing, from the daily reports to any sort of ad hoc analysis that you want. It's really flexible, and again, infinitely scalable.
Mm-hmm. I know we even discussed potentially using even a few other third-party things. I think on this slide we have Flume written down there. We were looking at potentially pulling together some other open source technologies to solve that problem, but we were looking at it as if SQS gives us everything we need and it's off the shelf, it's integrated, but it also integrates with CloudWatch and all those type of metering tools that Amazon provides. It made no sense to go in that direction either.
Great. Well, thank you very much for those answers. Also, we have another question here in reference to the scaling challenges that you and your team had during the project, Joe. What were some of the issues that you guys faced, and how did you overcome them?
I would say, first of all, one of the issues was latency with those front-end web servers. Really, really crucial to keep that to a minimum, as that's something that actual users of the video network would experience. And so trying to minimize that, trying to optimize our web server code to do that was a challenge. With our architecture, it was always possible to solve the problem by simply throwing more resources at it. You can just add more edge nodes if one is overloaded. But you also want to keep that within reason. So if each node isn't performing where it should be, that's still an issue. It's going to drive up cost. So we spent some time trying to optimize there. Other than that, since so much of this is using AWS's kind of out-of-the-box pre-built solutions, scalability was very easy. SQS, again, scales pretty much infinitely. S3, EMR, all of it scales really well. The worker nodes, again, weren't too much of an issue. There's some slight optimization we had to do there, but exact same story. If it really is an issue, you can very easily just add more nodes, and it's just a matter of trying to keep costs down. So I don't know if, Will, you have anything to add, maybe some more stuff that you saw in production.
Yeah, well, I mean, it's the I guess really exactly what you said. With that adding new nodes, you also are getting resilience. Even you have on your chart here using different availability zones. It also helps distribute risk. By having these things. Also, when you can create machines that are completely stateless, and you can spin them up in any zone, and they just go home and register themselves, and it's a wonderful thing. I love that. Just being able to know that that we can scale, but also when we scale, we're also gaining a disaster resilience. Oh, you want to mention the robot army you created to generate data? I mean, that was another nice heck. We didn't have the ability to get production level data volumes in to test the environment, but with AWS we were able to test it by generating traffic.
Yeah, that's true. We started out trying to just run a kind of web traffic generating program on our laptops, and just no matter how hard we tried, we weren't able to hit the production volumes. So we ended up going to kind of a cloud-based service where they actually spin up AWS EC2 instances to generate that traffic, and we were able to point massive amount of traffic at our development system for testing, and that was really, really beneficial for testing scale.
Mm-hmm.
Excellent. Well, thank you very much, Joe, and thank you, Will, for your time today. As I mentioned, this webinar will be recorded and will be on our website, so you can find it at thinkbiganalytics.com. And I'd like to thank you all for attending today and for your questions. If that's it, we're going to wrap it up now, and everyone enjoy the rest of your day. And again, thank you, Joe, and thank you, Will.
Great. Thanks for having me.